All right, so we're going to go ahead and move on to solve higher order equations with factoring. And this is the same type of thing as solve by factoring. We still want to just get it completely factored so that we can set each factor that contains a variable equal to 0 to get our solutions. However, we might see something that we haven't seen before. So we have additional methods for solving these higher order equations, okay? One is to solve using substitution, which we'll see some examples like that here in just a little bit. And basically this allows us to replace a quantity with a letter. That way we can easily factor it. And then once we have it factored, we can plug back in the original quantity. So I'll show you some like that in just a minute, but I want to start with a couple of examples that many students miss because they forget about greatest common factor. Okay, and if you forget about greatest common factor, sometimes you are missing out on solutions, okay? So let's go ahead and look at a couple of examples. This first one says solve the quadratic, well, they all say solve the quadratic equations, easy enough, and, or not quadratic, just solve the following equations. Okay, I will read the instructions instead of just making them up. All right, so what a lot of people will try to do when they see something like this is just to divide off x's, okay? And we don't want to do that. We don't want to divide off variables if we're solving for those variables, because what we're doing is we are eliminating some of our solutions or our potential solutions. So what we want to do, just like anytime we solved by factoring, is we want to make sure this is in standard form. So we want all the terms on one side in descending order so that it's equal to 0. So I'm going to start by moving my 20 back over to that side, okay, my 20x squared. And I do that by subtracting. So I have 5x to the 4th minus 20x squared is now equal to 0, okay? Once everything's on one side, then I look for my greatest common factor, okay? Look for the greatest common factor. So notice here, both of these are divisible by 5. They also have an x squared in common. So I can take out a 5x squared, and when I take 5x squared off of this term, I'll be left with x squared. When I divide 5x squared off of my second term, I'll be left with minus 4. Okay, so notice from here, this is actually now a difference of squares, right? This is a perfect squared term, this is a perfect squared term, and it's being subtracted. So I'm going to put a note here. This is now a difference of squares, and we know that that factors into the first base plus or minus the second. So my base being squared here is an x, my base being squared here is a 2, so this should factor into x plus 2 times x minus 2. And I just bring down my greatest common factor, set it equal to 0. So now I have it completely factored. So just like we did in our factoring section, we just set each factor that has a variable equal to 0 so we can solve. Okay, so what this means is, oops, move my paper, 5x squared equals 0, x plus 2 equals 0, or x minus 2 equals 0. So I just took each of these factors and set them equal to 0 so I can solve each of these little miniature equations. Okay, so on the first one I divide off my 5. So I have x squared equals 0. And then remember, we just learned a few sections back to get rid of a square, we can square root it. So I'm going to square root x squared. We always remember our plus or minus on the other side. Now here it doesn't really matter because when we do the square root of 0, it's 0. And whether we do positive 0 or negative 0, it's still just 0. So here we get x equals 0 as a solution. When we solve our second equation, we move our 2 over by subtracting, and we get x equals negative 2 as a solution. And then our last one, we move our 2 over by adding. We move our 2 over by adding, we end up with x equals positive 2 as a solution. Okay, so not too bad, right? Factor completely. With these higher order ones, it may just be something as simple as taking off a greatest common factor and then factoring what's left over and setting each factor equal to 0 and solving. Okay, so let's look at another one. Same idea. We have negative 13x to the 5th minus 637 x cubed. So again, I need this equal to 0. So I can either move my 637 this direction, or I can move my 13 that direction. It really doesn't matter. And I always like my highest degree term to be positive if I can help it. So I'm actually going to move my 13 this direction. Now, if you do it the other way, you'll still get the same answer, okay? So I'm going to move 13x to the 5th by adding, whoops, let me write the right number here, 13x to the 5th. So I have 0 is equal to, now remember, we always want to write it in descending order. So my 13x to the 5th is my highest degree, okay, minus 637x cubed. And then just like the last example, I always want to start by looking for a greatest common factor, okay? In this case, both of these numbers are divisible by 13 and they have x's in common. So I can actually take out a 13x cubed. And when I do that, my first term is just going to be left with x squared. My second term, if I do 637 divided by 13, that's going to leave me with a negative 49, right? And I took x cubed away from it, so it no longer has an x. And then just like the last example, this also happens to be a difference of squares, right? Because here my base is x that's being squared, here my base is 7 that's being squared, and I have a subtraction. So I know that this piece should factor into x plus 7 times x minus 7. And then I just go ahead and bring down my greatest common factor, which was 13x cubed. Once I have it completely factored, then I just set each of these factors that have an x equal to 0. So this means 13x cubed equals 0, x plus 7 equals 0, and x minus 7 equals 0. And then I just solve each one. So here I'm going to divide off my 13, and I'm left with x cubed equals 0. And the only number that I can cube and get 0 is 0 itself, right? So this means x has to be 0. My second one, I move my 7 over by subtracting, which gives me x equals negative 7. And then my third one, I move my 7 over by adding, which gives me x is equal to positive 7. Okay? All right, so this was our first case. Our first case was these higher order ones that we can basically resolve the issue by just taking off a greatest common factor, and then what's left over we should be able to factor. So now I want to show you the second case. Well, actually, I wrote the first case up here, which is solving by substitution. Okay, solving by substitution is what we're going to use on these next couple of examples. Because right here, this is not pretty, right? This is just nasty. If I wanted to solve this, I would have to do a whole lot of work. I would have to write this quantity twice and FOIL it all out, and then distribute this -4, and then combine all that mess so that I could factor it. And that's just a lot of work just to get to the point where I can factor. But what I notice is that I have an item being squared, and then I have that same item here, right? And it's equal to 0. So this actually kind of mimics ax squared plus bx plus c equals 0, right? It kind of looks like our standard quadratic equation. The only difference is instead of having just regular x's, you know, going from x squared down to x, here we have a quantity squared, and then it goes down to just the quantity, right? So what I'm going to do is I'm just going to replace that quantity with a different letter. So I don't have to worry about the quantity. So I'm going to come down here and I'm just going to say, excuse me, I'm going to pick a letter. Now, it doesn't matter what letter you pick. I'm going to pick M. Sure, why not? I'm going to say let M equal x plus 2. Okay? So basically, I'm wanting to replace anything I see that looks like that quantity with an M. So now my equation will look like M squared minus 4M minus 21 equals 0. Can you see why I wanted to do this? One, it gets rid of the ugly quantity, and two, now this looks like something that I can easily factor with my sum product chart. Okay, so I'm going to go ahead and do my sum product chart. my sum would be a -4, and my product would be my leading coefficient, which is 1, times my last coefficient, -21. So -21 would be my product. So something that multiplies to -21 that I can combine to get -4 would be -7 and +3, right? Because a -7 plus 3 gives me my -4. And because my leading coefficient is a 1, right? Then I can use my shortcut. Yay for shortcuts. So I know this is going to factor into m minus 7 times m plus 3 equals 0. And now that I have it factored, I want to set each factor equal to 0 so I can solve. So m minus 7 equals 0 and m plus 3 equals 0. Okay. When I solve this first one, I move my 7 over. So I get m is equal to 7. On the second one, I move my 3 over by subtracting, and I get m equals -3. Now, don't circle these, please, because these are not our answers, right? I got answers for m, okay? Notice our original problem had x's. So once I have solved for m, which is the letter I substituted in, I need to plug it back in. So I'm just going to say plug back in. Don't forget to plug it back in, okay? So what we used for m was x plus 2. So I'm just going to put x plus 2 now where I have an m. I'm just going to plug it back in. So if I have m equals 7, that really means that x plus 2 equals 7, right? And if I ended up with m equals -3, what that actually means is that x plus 2 equals -3. And now I can solve for x, which is what I'm actually solving for. So I'm just going to subtract 2 from both sides. So I get x equals 5. And I'm going to subtract 2 from both sides on my second equation, which gives me x is equal to -5. Okay? So really from here to here, this is what we've done before, factor and solve. The only difference is we started this factoring by replacing a quantity with a letter so that it was something that was really easy to factor. And then once we got it factored, plugging that quantity back in so that we get our actual answer. Okay? All right, let me show you one more just so that we see it again, and then I'll have y'all try some. All right, so again, notice I see my quantity squared, then it goes down to just a regular quantity, and then a constant term, and then it's equal to 0. So again, I'm going to see if I can replace this quantity with a letter, and if that will help me to factor it so that I'm not dealing with that ugly quantity. So again, I'm just going to say and I'm just going to use m again. Now you can use whatever you want. You can use K, L, A, whatever your initial is, okay? But I'm going to use m. I'm going to let m equal the quantity x minus 3. So now I can rewrite my equation as 3 times m squared minus 17 times m minus 6 equals 0. Okay. All right, so now that I have my quantity replaced, this looks more like something I can do with sum product, right? I look for a greatest common factor. I don't have one. So I go straight to my sum product chart. So my sum here is -17, and my product is 3 times -6, which gives me a -18. Okay. Now, something I can use to multiply to get -18 that combines to -17 would have to be -18 and a +1, or -18 plus 1 to get -17, right? But I cannot use my shortcut. No shortcut, because my leading coefficient here is not a 1. Right? And if my leading coefficient is not a 1, I can't just say these are my factors. So I'm going to take these numbers and I'm going to replace this middle m term so that I can do grouping. So this will give me 3m squared. Then I'm going to put in -18 and 1. and for this middle term. So make sure you put the m label on it. So negative 18m plus 1m minus 6 equals 0. And now I can group. Okay. So out of the first pair, I can take out a 3m. When I take out a 3m, my first term will be left with just an m. My second term, 18 divided by 3, is going to leave me with a negative 6. Okay, and I'm hoping to be left with m minus 6 over here. And I actually already have that. So if I already have what I need, I still have to take something out. But the one thing I can take out that doesn't change the value is a positive 1. So I'm going to take out a positive 1. And when I divide both terms by a positive 1, of course, I'll end up with m minus 6. And now that they both have the m minus 6 quantity, I'm going to go ahead and take that out, which leaves me with 3m plus 1. Okay, so now I have it completely factored. So I want to go ahead and solve each factor. So m minus 6 equals 0, and 3m plus 1 equals 0. Okay. All right. So I'm going to add 6 to both sides. So I get m equals 6. On the second one, I'm going to subtract 1. So I get 3m is equal to negative 1. And then I divide off my 3. Okay. So I get m equals negative 1/3. All right. So I have my answers. Notice I did not circle them because what I solved for was m. And what I need answers for is x. So now that I know what m is, be sure to plug back in. We must plug back in. So we ended up with m equals 6 and m equals negative 1/3. So I want to go ahead and plug back in what my original m was standing for. So we let m equal x minus 3. So this means that x minus 3 equals 6 and x minus 3 equals negative 1/3. Okay, so I just need to work out these two options, right? So on this side, I just need to add 3 to both sides. So I get x is equal to 9. Excuse me. And on the other side, I need to add 3 to both sides. So I have x is equal to, now I can't combine these as it's written, right? So I'm going to write this as 3 minus 1/3. And in order to combine fractions, I need a common denominator. You can write this as 3 over 1, or you can use the fraction button on your calculator. Okay, my common denominator here would be a 3. So I'm going to rewrite this as something over 3. So in order to get a 3 on the bottom here, I need to multiply on top and bottom by 3. So that will give me 9/3. Okay, so 9/3 minus 1/3 gives me 8/3. And we just leave it like that. Okay, so on these substitution ones, we're just choosing a letter to replace that quantity. Once we have the quantity replaced, it should be something we're able to factor. Okay, once we factored it and solved and gotten our answer for our substituted letter, then we need to plug back in for what our substituted letter represented and go ahead and solve for the actual variable. Okay, all right, so there are 2 for y'all to try on the next page. So go ahead and pause the video and work those out. Whenever you're ready to check yourself, or if you get stuck, go ahead and play the video and we'll see how you did. All right, so on the first one, this is one that we cannot solve by just dividing off powers of x, right? Because that would get rid of answers. So we start by first moving everything to one side. I chose to move the 144x squared. Then these two terms have a greatest common factor of 4x squared. Once I take 4x squared out of both terms, I'll be left with x squared minus 36, which is a difference of squares, right? X is my base here, 6 is my base here. So this will factor into x plus 6, x minus 6, and then I set each of these factored, each of these factors equal to 0 and solve. So my answers should be 0, negative 6, and positive 6. Okay, let's go ahead and look at the second one. The second one, we need to do substitution, right? And on this one, I chose Y. Why, you ask? I don't know. You can choose any letter you want. So I chose Y. So I let Y replace our quantity, x plus 6. So that gave me a y squared minus 5y plus 6. Now, if you chose m, you would have m squared minus 5m plus 6. If you chose whatever letter, okay, you would have your letter in place of y's. All right, so this is something I can factor using the sum product chart. I need something that multiplies to 6 and combines to -5, which would be -3 and -2. Because my leading coefficient is a 1, I can use my shortcut. Okay, so this factors into y minus 3 and y minus 2. When I set those equal to 0 and solve, I'll get 3 and 2. Now these are my solutions for my substituted variable, not my solutions for my final answer. So once I have my solutions for my substituted variable, I have to substitute back in what that variable represented. So here I replace the quantity x plus 6. So I'm putting x plus 6 back in for y and solving, which should give me a -3 and a -4. Okay? All right, so that is the end of solve higher order equations with factoring. So you should now be able to complete that assignment in Knewton. And then you should also be able to do the worksheet that's called solving equations. Okay, so it's kind of a review of all the different solving methods that we have done. Now on that worksheet, you can use any of the methods that you would like that are applicable to the question. Okay, so I don't care how you work it, as long as you show me your work so that I can see that you factored it or used the square root property or completed the square or use the quadratic formula. Okay, so this assignment and that worksheet will now be due, and that concludes Unit 3. So don't forget to prepare yourself for the Unit 3 exam. Okay.